So number 8 here, number 8 a little bit complicated. Okay. So number of the radioactive nuclei, okay, in two different samples, P and Q, initially 4N and N. So it means that we have a sample P. Initially, you have 4N. Initial, we just consider as the initial mass lah. Okay, and then the sample Q, initially we have the mass is N. Okay, so if the half-life of the P is T, half-life of the P is T, right? And then the half-life of the Q is 3T. So 3 means the half-life of Q is longer. So it means that Q have the lower decay rate. Lower decay rate. And then the P is higher decay rate because the P, the time half-life is shorter. It's only T. But the Q is a 3T. So the number of the radioactive nuclei in P will be the same as the number of the radioactive nuclei in Q after a time of when. Okay, so now beginning their difference. P have 4N, Q only have N. So now the question asks when they're going to have the same numbers, same number of the radioactive nuclei. Okay, so beginning their difference. So we only can try get to know when they're going to same is after the half-life. After half-life. Okay, so let's say N after half-life. The half-life for the Q here is 3T. After 3T, N becomes N over 2. Okay, but the P after a half-life is after time T, so it becomes 2N. After another half-life, a time T, it becomes N. After another half-life, so it becomes N over 2. So for the P, now it seems like we have a same already, N over 2. Okay, P goes through 3 half-life. Q only goes through 1 half-life. But the time taken, both have the same time taken, 3T. P after 3T become N over 2. Q after 3T become N over 2. Just only P have 3 half-life, Q only go through 1 half-life. But because the Q beginning we have less. So less, but with the lower decay rate, so even after 3T, it only reduce half, so it become N over 2. But the P beginning have more. But the problem is P have the higher decay rate. So that's why after 3T, it will straight away become N over 2. Right? Because after 3T, it will go through 3 half-life. So from 4N, it becomes N over 2 already. So it means that both they have the same number of radioactive nuclei after time of 3T. Right? So, okay. My question is, the additional question on this is that any possible for P and Q will be same against the number of radioactive after the 3T? Is there any others possible for both of them have the same numbers of the radioactive nuclei again? Please respond in the message. Anyone? Is there any possible for P and Q they will be same against after the 3T? If yes, when is it? If no, why? So now beginning there are 4N and N, P and Q. All right. The number of nuclei. So now after 3T, they become the same. So now my question is, after that, after 3T, is there any other possible for them to become same again? If yes, when is it? If no, why? Okay, Hannah, 60. So if you ask is 60, then now we try 60. What happened? Okay, so let's say continue from here, 60. So after another t here, so it becomes n over 4. Another t, n over 8. Another t, n over 16. Okay, for this one, q, after 3t, 1/2 right only, right? 1/2 right only, so it's n over 4. Are they the same? They are not the same after 60. They are not the same after 60. After 60, p is n over 16, but q is n over 4. So now, obviously, the answer is not 60. Any others? When they're going to be a same again? Raise anyone as one? Girls?
Teacher, is it that they won't have the same amount because the rate of decay for P is faster than Q?
Right. Okay, Angeline. Okay, never, because P will decay faster than Q. Okay, so, all right. Okay. The answer idea is correct, but the answer is wrong. I repeat again. Angeline, your answer idea is correct, but somehow your answer is wrong. You know why? Does anyone know why the answer idea is correct, but the answer is wrong? Okay, so sorry. The way you write like this, okay, you still got chance to get correct answer lah. This one decay faster. All right. Okay. So because you mentioned decay faster, once you mention the decay rate is faster, then it will be answer will be wrong lah. But if you mention decay faster, yes, correct. Okay, sorry for that. But for those, if you answer decay rate or the rate of decay is faster than Q, your idea is correct, but the answer is wrong. Because once you mention about the rate, means that the idea is included the time. So please remember, once the idea included the time, you cannot use faster or slower to describe about the time. Includes the rate. You cannot use faster rate or slower rate. That's why you see the textbook on the comparing the decay curve, we only mention decay rate higher or lower. We don't tell you faster rate or slower rate. Sometimes, yes, the answer will accept faster or slower rate, but most of the time they will reject. So I don't know when they're going to accept, when they're going to reject. But for the safer, please remember, do not mention faster or slower rate. I think in chemistry also same. They are not allowed the students to use faster or slower to describe about the rate. Okay, so you have to mention higher or lower rate. Okay, please remember that. Okay, so that's the correct answer. Because the Q will decay faster due to the higher decay rate. So once the beginning started, after 3 times, they have the same numbers of nuclides. So when they start with the same number of nuclides, but the problem is the P always decay faster. So it means that the P will reduce faster than Q across the time, over the time. So once over the time, it always decay faster. So the rate is higher. Therefore, They're not going to have any chance for the P same with the Q against, because P will always less than Q after that. P always less than Q across over the same interval time. 1 second, 2 second, no matter how lah. As long as after the 3T, any 1 second after that, it will make the P less than Q all the time. So that's why they're not going to have a same again, never. Right? Because they are decay on the different rate. Right? Clear? So this one, it can become the essay question, ask you to explain short essay. Right? So you have to say that, example, mark 1, you have to say that the decay rate of the P is higher than Q, so 1 mark. Due to the higher decay rate, so the P will decay faster, 2nd mark. So after the P decay faster means every in same interval time, the P always less than Q. Therefore, the conclusion is the P the P and Q never have the same numbers of nuclei against after the time 3T. So altogether 4 marks. Right? So there is an example that it will be asked.